morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video, Additional Mathematics. So looking at vectors in two space. Two space simply means vectors in two dimensions. These are example questions. So we have a certain example, which is, in this video we're going to do question 1A, and then in the next video we're going to do B, and so on. We're just going to be doing questions like that. So it will be small video clips. Alright. So the question reads, question A, write a vector equation for the line through the points A 4, 1 and B 3, 1. So we have the point A is a 4, 1, and then point B is a 3, 1. Alright, so now you want to use coordinates to come up with a vector equation. There's something that we need to know. We need to find a direction vector. That's the first thing that should be coming to your head. Direction vector. When you're finding a direction vector, you need to follow the formula for finding gradient. So let's label these as our x1, y1, then x2, y2, then m, representing the gradient, is equal to y2 minus y1 divided by x2 minus x1, which is equal to y2 is positive 1 minus y1. In this case, alright, I switched the coordinates. It's actually 1, 4. Sorry for that. So it's actually 1, 4, then 3, 1. So our y2 is 1 minus our y1 is a positive 4. X2 is a positive 3. X1 is a positive 1. This will give us negative 3. And then here, when we subtract, we're going to have divide by 2. Therefore, our m is equal to negative 3 divided by 2. So if you have a negative sign, what I recommend, instead of writing your fraction like this, for example, negative 3 over 2, this is the correct way of writing a fraction, representing that the fraction is negative. Now, I've written it like this, kind of entailing that the negative 3, that the 3 is negative, right? Negative 3 is on top. I want you to flip it. So I want this fraction, negative 3 over 2, to become 2 over negative 3. That's what I want that fraction to become. Alright? So if you want to find the direction vector m, like that, with an arrow on top, like that, is equal to 2, negative 3. So in writing the direction vector, we write it in the column vector form like that. Or it's also the same as saying direction vector D. Alright, you can represent it as m or d is equal to 2, negative 3, and that's a direction vector. After you know your direction vector, everything now is easy because you know the format for your vector equation. The format for the vector equation is as follows. So we have x, y is equal to x naught, y naught, plus the parameter t multiplied by m1, m2. Then x naught, y naught, these represent the position vectors. m1 represents the x-coordinate of the direction vector. m2 represents the y-coordinate of the direction vector. And this is the direction vector. So this is our m1, this is our m2. So m1, this is our m2, just like that. So if we are to write the final answer, therefore x, y, representing the vector equation in the column vector form, a position vector is a coordinate that starts from the origin. Alright, so it is like a vector, rather, a vector that starts from the origin. Here you can see this is a coordinate. It is a position vector, because a position vector is a particular type of vector that starts from the origin. Not all vectors start from the origin. That's a point you need to note. So I can get any of these. I'm going to choose 3, 1. So 3, 1, like that, because this is the x component, this is the y component, plus the parameter t, then we have 2, -3. If you want, what you can do is, or x, y is equal to this coordinate there, 1, 4, plus the parameter t, and then direction vector is maintained to -3. And that is, so that right there, let's just clean up so we're not confused. This right here is your final answer. You don't need to put the or. I'm just saying, if you write this or that, both are correct. Thank you so much for watching. This has been Cornelius Lubinda with another video. I'd like to sincerely thank you for that, for the support you're giving me, and bye bye.